All right, so last week we went over graphing. Okay, so we know how to build a graph. Friday we went over how to build a graph using Google Sheets. Okay, so today we're going to put those skills together with some real data that we're going to go and acquire. All right, so we're going to have fairly straightforward lab where we're going to investigate what the relationship is between distance and time for an object traveling at a constant speed. Okay, so that's the problem that we're investigating. The relationship should be evident from our graph. Okay, the shape of our graph and the trend of our points will tell us whether it's a linear relationship, an exponential relationship, or a polynomial relationship, or inversely linear, whatever. Okay, if it's linear, that means our graph should be roughly a line. Yeah, roughly a straight line. Okay, if it curves off, then it's something else. Okay, but if something is traveling at a constant speed, does that mean it goes the same distance every second? Yeah, if something's traveling at 3 meters per second, every second it goes 3 meters. Okay, so we should have a relatively straight line on our graphs for these incredibly sporty toy carts. Okay, now we're going to run 5 of these. We're going to take them outside to the track, where we're going to run them down a lane. Now, my period ones did not listen to my instructions, and I hope they're all listening to this podcast later. Okay, and it was the worst I've ever seen. Okay, you have to. These carts, they're not very good. They're crap. Okay, but I mean they're dollar store carts. You get what you pay for. They don't go straight. Okay, so you have to steer them a little bit, and they're not remote controlled. Okay, so the way you steer them is we're going to put them on one of the lane lines on the track, so we have a nice straight line as a guide. Okay, and then the person who's steering the cart, as the cart moves along, so the cart moves kind of like this, they're just going to straddle it and kind of gently nudge it and keep it in a roughly straight line. Okay, it's not hard, right? And so. Right, you just kind of gently nudge it with the side of your foot, and look at that. I made it travel the whole way, the whole length of the classroom, right on the seam between these tiles. Okay. When we were outside, the lane line is 2 inches thick, and the placement markers we had, they looked like, here's the lane line, and our markers went like this in period 1. Like they were 2 feet beyond the line in some cases. And then one person kicked it, and it went tumbling over, so we had to start over twice. So yeah, you guys following my instructions here? I'm making fun of period 1 because they deserve it after that performance. So we're going to keep those straight with gentle nudges of our feet. If you've ever dribbled a ball in soccer, it's the same action with less force. You know how when you're dribbling a soccer ball, you just use the side of your foot gently? That's what we're doing, but even more gently than that. We're not trying to bend it like Beckham. We're not trying to do that. All right? So just so you know, that's what we're doing. I will also have one person who will be a marker. That person is going to be working in conjunction with our timer. So we'll have one person who's using the stopwatch on their phone. Every 5 seconds, you will tell the marker they need to put down a sticky note. And what the person will do is place a sticky note on the track where the front of the cart was at that time. And we're going to do that for 40 seconds. Down the track. No, I'm going to walk by after we got all the markers with the trundle wheel and tell you how far each one is. And then we're going to fill in the spreadsheet, and we'll be able to make the graph from there. Taylor, question? Oh, it's not groups. We're all going out there all together. Yeah, I know it says on their group, but I changed the procedure a little bit. Yeah, everyone's going to have exactly the same data, which is nice because then when I'm marking it, I know whether you did it right or not because I know what the numbers are. Everyone follow me on that one? So it's really, you shouldn't be able to screw it up. It's a pretty straightforward lab. So that's what we'll be doing. Now, before we go out there, a couple of things. Obviously, we need to have a hypothesis for this lab, same as we always do, if, and then statement. The if part should be telling us what the relationship between distance and time is. And we just said it's most likely to be a straight line, which we call a linear relationship. All right, so probably in the if part of our hypothesis, we should talk about that. Okay, the and part describes what we do, same as always. And the then part should tell us what's our graph going to look like. Okay, we've said it's this kind of a relationship, then our graph will look like this, and you fill in the blanks. Okay, for our variables, for the design part, we said when we first started working on graphs that if time was involved, time would always be which variable? Always. Okay? It's always the manipulated variable because we are setting the time limit on this experiment. And the time limit is 40 seconds. Okay? We're also setting the measurement interval every 5 seconds. Okay? We're measuring the distance every 5 seconds for 40 seconds. So we are completely manipulating the time portion of this experiment. All right? Responding to how long we allow the carts to travel is what? The longer I allow the cart to travel, the further it is going to go. Further is a measure of distance. Okay, so distance will be our responding variable. Okay, these carts, okay, when I turn a cart on, it travels at a constant speed. Generally, if something is constant, it's a certain kind of variable. No, we talked about manipulating and responding, so things that stay the same are controlled variables. All right, so speed of the cart is a controlled variable because the speed of the cart does not change as the experiment progresses. It's traveling at a constant speed. Okay, and then there are a number of other controlled variables. When we get out there, okay, you'll be able to see kind of what they are, okay, as the experiment progresses. Note to yourself here. I've told you what essentially all of the variables are. Okay? The most common mistake I see is people not listening and saying that the carts are the manipulated variable. They are not. Okay? We are not comparing the carts in any way. We just want to have 5 sets of data to compare, okay, or so that we can compare distance and time 5 different times. We're not. The carts are independent of each other. Does everyone follow me there? So really, we've already said that the thing about the carts is a control variable. Okay? The speed of the carts is a control variable. Yes, we're using 5 different carts, but we're not comparing them. Okay? We're comparing distance and time. Everyone follow on that one? Okay? Because inevitably I have people do that. So now I've said it like 5 times. If somebody does it, then I can justify giving them a big fat 0. Okay? All right. The procedure, you're going to have to, in Google Sheets, I'll come back and we'll show you how all that works, fill in the spreadsheet. Okay, I have given you in your, oh sure, now that's going to quit. Oh, right, because I've got a pen in my hand. That's why. Okay, so in the Graphing Lab, when you click on that, there'll be 2 things you can fill in. Okay, there'll be this one here that says Graphing Lab and it'll have your name on it. That's the spreadsheet. Okay. And then there'll be the Graphing Lab report template that you have to fill in. Right? But right now, before we go outside, because we're not taking the Chromebooks outside, there's no purpose to doing that because there's no Wi-Fi out there. Okay? I need you guys to, by hand, create this chart just so we can record our data while we're out there. So it doesn't need to be neat. It just needs to have that shape with that many boxes so that we can record all the distances. Okay? So along the top, 5 seconds, 10 seconds, 15 seconds, 20 seconds. Okay? If you want, and I would probably suggest that you do this, what's their position or distance going to be at time 0? 0. That way every single one of your lines will start at the origin. Okay, but we can add that to the spreadsheet later. For now, we just need enough to record the data outside. Okay, the carts we have are cart 8, 5, 7, 10, and 6. I know that doesn't go in order, but okay, we used to have like 10 of these, but we had to start stripping them for parts to keep 5 alive. Okay, so yeah, those are the numbers of the carts we'll be using. All right, so on Google Classroom, obviously the Graphing Lab is already on there. I put it up last night. Okay, these 2 documents here are, one of them is the handout, okay, that I didn't photocopy because I'm not photocopying that stuff anymore, okay. So if you need to see basically the whole thing, okay, it's there. And then this is the data for people who aren't here today and don't get the data, okay. They can get that document there if you lose yours or whatever, okay. If you click on the Graphing Lab, right, then it opens up the page that looks like this, okay, and it shows you the two things that you can modify. All right, one of them is the spreadsheet, and one of them is the Google Doc for your lab report. Okay, same as it kind of always is. So you're going to fill in the spreadsheet, which looks like this, like so. Now, right now, when you open yours up, it's going to say time in seconds, and it's going to say cart 1, cart 2, cart 3, cart 4, and there's not going to be a fifth column there. Okay, just because for whatever reason I forgot to put in a fifth column when I built it. So it's not that hard. Okay, you just change the numbers to 8, 5, 7, 10, and 6, or whatever order we did it in. Okay, and then you'll be filling in the data from there. Does everyone follow me on that? Okay, when you have the data filled in, then you need to copy this chart over into your Google Doc for your lab report, because when you open up the lab report, it says copy and paste your Google Sheets table, that's this, okay, and your graph, which you will use this to build, into that spot. Okay, so both that chart and your graph needs to go here. We're going to put all 5 carts on the same graph, so we only have one graph. It says graphs, plural, but it should say graph, okay, because we're putting them all on one graph. Now, we had a little bit of issue with copying the chart over this morning, okay, but one of the students in period 1 was really on the ball, so I'm now paying a compliment to period 1, okay, she was really on the ball, okay, and yes it was, and she showed us all a really great way to get it to work properly, right? The key here is this, and I'll show you what she did, and it'll make your life a lot easier. What you're going to do here is first go up to put your cursor right where mine is. Okay, so right down below where it says copy and paste. You're going to click insert and you're going to go to table. Okay, now we need that table to be, what is it here, 10. We need it to be 10 by 6. All right, 10 deep or 10 tall by 6 wide. All right, so when we go over to here, we go insert table, and then it asks us, how big do we want it? Okay, so we say we want it to be 10 by 6. Click on that and it puts the chart in. Now, you go over to your Google Sheets, you highlight when you have all the data in there. Don't do it now when it's blank, okay? After you have all the data points we got in there, you click copy, and then you go into here with your cursor in there, just paste. Okay? And it'll all go in, and you'll be able to read everything. The issue we had this morning was it shifted everything over and you couldn't see any of the numbers. The chart came over, but you couldn't see the numbers. All you could see was shun meters in every column, so it didn't work out very well. Right? Now it's copied over. Okay? Build your graph now, then insert that. Okay? After that, and then there's only one analysis question to answer. And that is, calculate the velocity of each cart. So what we got to look at is, when we build a graph of distance and time, okay, so our graph, when it's done, is going to have distance in meters, okay, and time in seconds, and it'll have our points, but we'll have these best fit lines. Everybody with me there? Okay. We want to have Google Sheets do everything we worked on Friday. That is, we want the label to be the name of the cart and the equation for the cart. So remember that in the equation, it tells you the slope, and it tells you the y-intercept. So it goes y equals, and then whatever the slope is, times x plus whatever the y-intercept is. And for, I think, just about all of these, the y-intercept will be 0. Okay, because our first point for all of them is 0. So it's likely to be near 0. If my graph looks like this, and I'm trying to find the velocity of the cart, okay, what about my line will be equal to the velocity of the cart? The slope. Okay, and here's why. When I calculate the slope of this line, I'm dividing the rise distance by the time, which is the run. Okay, so when I calculate the slope of this line, I'm going d over t, which is the same as calculating speed. All right, so what I want to see in your analysis, in your lab report, is that calculation, which you can do in one of two ways. You can find 2 points on your graph and go rise over run and show me your calculations, or you can manipulate y equals mx plus b and show me your calculations for each line. Yes, I realize the number will be in the equation already. You have to show me how you would calculate it. Does everyone follow? For every line. Okay? Now, you can do that, typing it out in the Google Doc, but if you're not comfortable doing it that way, do it on paper, snap a picture of it, and insert the picture in for your calculations instead. Okay? I'm fine whichever. All right, so you can do rise over run, or you can manipulate y equals mx plus b. Either way, I want to see 5 slope calculations, okay, in the analysis there. Remember units, okay? And then you'll have, same as always, your conclusion and evaluation. Okay, so you restate your hypothesis and tell me why you can accept or reject it. Okay, and then, man, there should be no shortage of sources of error given the way we ran this experiment, okay? Because there's a lot of eyeballing and all that kind of stuff. So yeah, there should be plenty of sources of error to list, and you got to think up, remember, ways to improve them. All right, questions? All right, you've got about a half an hour of class time to work on that. You should be able to get a pretty good portion of that done, I would think, okay? Because the graph won't take you very long. Right? You just got to punch in the numbers and it'll do it all for you. So due date, guys, is May 7th. That's Thursday. Right? So that's coming right up. Okay, this came up in period 1. We saw this problem happen in period 1. You can see that in the headings, I've already put the units in here. If you put m's in here, it won't let you graph it because it doesn't know what to do with the letter. Okay, if it's not just a number in these squares, it gets confused. It doesn't know what to do with an m. It screws it up. It makes it confused. So you can't put m's beside any of these numbers. Just put the numbers in. That's why I put the units up here in the heading. Okay, so just in case that happens to you, because it does happen to 1 or 2 people, they're trying to do the right thing and include units, but the units are already included. Okay.